So we start to talk about the lubrication. So for this topic, that was included the lubrication theory and the lubricant, the introduction of the lubricant. So these are the some occasions or mechanisms or even some components that the require the lubrication. So usually it's a mechanical component. So like this door lock and also the window lifting mechanism from the automobile. Or here we have a pendulum clock. Okay. So these are the devices or components. Usually you have a mechanical movement from the tribological components, okay, especially for this door lock or in your house or in your automobile. Okay. Or here in the window lifting mechanism. So this is one of the design. So almost every relative moving component in an assembly require lubricant. Okay. So here we have another turnkey slice bolt into a notch on door frame. So what really the lubricant will help, will help it can reduce the stress concentration, or even you have some sliding path. So this is a transmission path. So transmission path means automobile transmission. Okay, especially for these four items or some bearings can follow or even some seal phase. So if you don't have any lubricant between the interfacing, a relative motion between the tribal pair, it may cause some phase failures. Okay? So because if you have a friction, then you will have some wear for the material. Then in that case, you will have a premature service life. So, so the presence of the lubricant will reduce the stress concentration. Okay. So the method of the replacing lubricant would decide the overall performance of the system. In your textbook, you will see some additional example for the application of lubricant in the journals or some any situation involving metal to metal contact, especially in this case. So adding some lubricant, you can reduce the friction, of course, the coefficient of the friction. So you can reduce the wear as well. So here we have some figures here. You can distinguish the Newtonian or non-Newtonian fluid. Okay. So so this is the formula you can classify the Newtonian fluid or non-Newtonian fluid. Okay. you have two different number of ends. Either it will, greater than one or smaller than one. Okay. So for smaller than one, which means if you have a relative motion between the interface, if you add in the lubricant, so if the viscosity is decreasing during the relative motion, it's called the shear thinning effect. So which means the n will be smaller than one. So once you have the viscosity increase according to the relative motion, then you have a shear thickening effect for your lubricant. So either of them, they are non-Newtonian fluid. Okay. So for us, usually in your fluid mechanics in undergraduate, usually we discuss about the Newtonian fluid. So like the ordinary oil liquid or water, so they are Newtonian fluid. Okay, so they satisfy, it satisfies it. So in your fluid mechanics, you have this formula. Okay. So this data here is you have this one. It's called dynamic viscosity. It's the viscosity divided by the gravity of the fluid. For the grease, so grease is non-Newtonian fluid. So if you have a relative motion between the interface and the grease will, the viscosity of the grease will decay. So it's called the shear thinning effect. Here again is the example for the lubricant in the combustion engine cylinder. So between the piston ring and the cylinder, we have some lubricant can inject into the inner surface of the cylinder. So it's a yellow one. It's a lubricant. So because for the piston ring and the cylinder, they need to be really with very tight movement. So usually we have a two piston ring. So the lubricant must form a film. In this case, for the combustion engine, So the lubricant should form a film to separate the inner surface of the cylinder and the piston ring. So, and also the lubricant need to attach or adhere to the inner surface of the cylinder. So, and then once the oil and air gets burned down, so you have some debris or some left over. So the lubricant in this case need to neutralize the corrosive product of the combustion. Okay. And also the lubricant should withstand a high temperature inside the cylinder. So this is the basic requirement for the lubricant for the for this circumstance to be used in the combustion engine. So this is one example. And the second example is the lubricant to be applied in the journal bearing. Okay. So for the journal, you have a heavy loading on the shaft. So the lubricant should be able to support the shaft and extra loading or external loading. Okay. So and that also it's better you can separate the two contacting surface. So then you will have the absence of the contacting stress. Okay. And for the journal bearing, it will be better you have a damping effect for your lubricant, so you can damp the vibration to absorb some of the vibration. This is a basic requirement for the lubricant used in the journal bearing. So this is the journal, the outside of the journal. This is the shaft. So if you have some loading condition like this, usually we will fill all the surface with some lubricant. So the lubricant should be able to at least satisfy these three requirements. So for different application regime or application cases, you need to have a different requirement for your lubricant. Here is another example for the lubrication in the bone joint. Okay. So this is the basic structure from our human leg. So we have a ligament to connect these two bones together. And here in between the red one is the joint fluid. Okay. So this joint fluid is behave like a lubricant. So here we have some description for the synovial fluid between these two bone joints. Okay, you have the lubricant will contain some proteins, protein 蛋白质 protein that stick to the cartilage layer, resulting in smooth sliding. So the coefficient of friction between these two bonds is about the 0.01. Okay? And then it contains also some of the minerals that nourish the cartilage cell. So increase the viscosity with increase in applied pressure. Okay. This is a human bone joint in your leg. Okay. We have also thick or thin lubrication. So when we talk about the lubrication theory, usually we'll talk about thick or thin lubrication. So which means the thickness of the lubricant between two contact or two triple pair or two contacting surface. So if this the thickness of the lubricant is bigger, so we call it thick lubrication. If the thickness of the lubricant between these two interfaces is small, we call it thin lubrication. So they are totally different characteristic or behavior for this thick lubrication or thin lubrication. So one point you can understand by watching these two drawings or two figures, you will know these two surfaces for the thick lubrication they are separate, so there is no physical contact between these two surfaces. But for this thin lubrication, for some asperity or for some high points, they are still contacting each other. Okay. So, which means for this thin lubrication, the coefficient of friction should be bigger than this thick lubrication, because for the thick lubrication, you don't have any physical contact. So usually, it's only the fluid friction. So the friction tend to be small, the coefficient of friction for the thick lubrication. But of course, you can have a more detailed explanation from to understand the thick lubrication by the Reynolds equation. Okay. For the thick lubrication is far more complex, so requires scientific study at nano or micro levels. Okay. So here are the lubrication theory or lubrication mechanism. So we always discuss some of the theory to describe different kind of lubrication. So in this case, there is a famous curve for this. It's called the Strybeck curve. Okay, So from this case, this is I think it's the sliding speed, so divided by the contacting pressure in the horizontal axis. The vertical axis is the coefficient of friction. So in this curve, we can divide the lubrication into three different categories. So the first one is called the boundary lubrication, so, which means the film thickness is very small. And then you have another one, it's called the mixed lubrication. So the third category is called the hydrodynamic lubrication. Okay. So how we can divide this lubrication mechanism into different categories? We are using the dimensionless film thickness. So this lambda value, this lambda value is equal to the h minimum divided by the rho mean square surface roughness from the first service and the second service. So this is so we have film thickness divided by the dimension, also the thickness of in a millimeter. So this lambda is dimensionless，所以这个是没有因次的油膜厚度，它其实是最小的油膜润滑油的厚度除上两个的那个表面粗糙度，两个接触面的表面粗糙度，平方开根号是均方根的平均的均方根。So you can look at this like dimensionless film thickness. Okay, lambda. So it's also called the specific film thickness. So if lambda is smaller than 1 is called the boundary lubrication. If lambda is greater than 5, it's called the hydrodynamic lubrication. So this should be moved to this one. So the second category is the lambda between 1 and 3. It's called the mixed lubrication. So for the electrohydrodynamic lubrication, lambda is between 3 to 5. For lambda greater than 5 is called the hydrodynamic lubrication. So, so this is the characterization in our textbook. But in some textbook you will see you have only three different categories. See, we have in your textbook, yeah, we have some four different categories for your striped curve, but you remember from this one, you have a different classification for that here. So this is another striped curve. So in this case, it is classified into only three different categories. So it's okay because uh, this is the result from the experimental, so from the experimental testing. So for different lubricant, you have a different result. So some textbooks they tend to have three different categories. But in a textbook, we have four different categories. So in any case, yeah, the number is also different. Okay. So this lambda specific film thickness lambda smaller than 1.2. So the second one is 1.2 is boundary lubrication. So between 1.2 and 3 is called mixed lubrication. So this mixed lubrication is a thin film lubrication. Okay. So when lambda greater than 3 is called the hydrodynamic lubrication. It's called a thick film lubrication, which means in this case, for the thick film lubrication, usually they don't have any, the, the tribal pair doesn't have any physical contact from the surface. Okay. So sometimes it's different. So for this transparency, it has only three different categories. Okay. But in our textbook, we divided them into four different categories. Right. So this is important for you to know the lubrication mechanism from the strike-back curve. So you need to know the definition of the specific film thickness. Yeah. So we can look at this lambda is specific film thickness between the service 1 and service 2. So and this lambda lambda ratio, you have some information between the film thickness and also for the surface roughness for the service 1 and service 2. Okay. Right. So when the specific film thickness is small, which means some of the asperities will having contact to each other. These two surfaces will have some physical contact, which means the possibility is high. So it's called the boundary lubrication. So this was first proposed. This theory was first proposed in 1922 from the English biologist, okay, which means a very thin upsole layer about 10 eyes thickness was sufficient to cause the two glass surfaces to slide over each other. So we have also typical some example here. A very thin layer of lubricant, a few molecules thick, 1 to 10 nanometer. Molecule 就是分子啊，这是一个分子的厚度，就是看你的润滑油的分子是什么。Separate the sliding surfaces, so there is no direct contact of the sliding part. So here are some examples in engineering equipment, such as the steel gear, piston ring, and metalworking tools. Depends on one or more of these lubrication modes to prevent severe wear or high coefficient of friction and seizure. Which means that you just add in some of the lubricant, even very small film thickness, it can prevent the high coefficient of friction or even some severe wear or seizure situation. So these are the boundary lubrication. So the oil needs additives. So we add some additives. So the lubricant will attach a long hair mechanism onto the surface. So when they are in contact, these long hair or long tail will slide on each other, so it can reduce the coefficient of friction. So, so the best boundary lubricant are the long chain molecule with an active N group, typically is the fatty acid. 所以最好的边界润滑的润滑剂的话，就是这种有常见的分子，而且它会有一个很有活性的那个尾巴，典型的就是一些的我们的脂酸 fatty acid。So later on we will discuss about the exact chemical composition or chemical name for the lubricant. Okay, we take a break. For the lubricant used in the thin film lubrication, the basic characteristic requirement here. So it's a long chain molecule with active ending group，所以它是一个常见的化合物，非常有活性的一个端长的端子。Attaching itself to the solid surface and building a surface layer. So it's dissolvable in mineral or lubricate in oil，可以溶解在矿物质或者是油里面。So it requires temperature stability. So typical fatty acids decompose at a temperature above 200 degrees Celsius and lose their effectiveness. 所以它的温度稳定性是在超过200度的话，就是会失去它的活性，会分解掉。所以它润滑油不可以在边界润滑的话，这种的是不能用在200度以上。So what are the effects of the Lancia molecule on boundary lubrication? The longer hydrocarbon chain, more effective separation between solid surface. So it can provide a high degree of slip and low friction lubricant friction. This is experimental results from Sir William Hardy experiment. So we have several different results. So this is the coefficient of friction in the vertical axis. The horizontal is molecule weight. So you have a paraffin oil. The second experimental result is so you have glass, steel, phosphor bronze, and bismuth. So this is the result, experimental result. So there are two different mechanisms for the boundary lubrication. The first one is called physical sorption. The second one is called chemical sorption or physical absorption. So this is a new word coined by these two words, okay? Or chemical absorption. 所以有两种边界润滑的机制，一个是物理吸附，一个是化学吸附。So for all the petroleum or synthetic lubricant having some potential for forming boundary film under the mild sliding conditions. 对大部分的石化或者是合成的润滑剂，它们基本上都有形成那个边界膜的一个倾向。Useful under light loading and low temperature conditions. So this is called physical absorption, 化学吸附 or chemical absorption or chemisorption. It's called the bond energies are much greater than the physical sorption. Okay. So it's greater than the 40 kJ per mole， 就是一摩大概有40千焦耳的那个吸附的能量。With polar or paraffinic molecule chemical soap lubricant can be very close packed on a surface. 对有极性或者是石蜡的分子的话，这个化学吸附的那个润滑剂的话，能够在表面上对很好的包裹住。More effective boundary lubricants combine the chemical reaction with the surface and the cohesion interaction between the lubricant species. So the mechanism of the boundary lubrication are usually controlled by the additive present in the oil. 所以到底是用这种物理吸附或化学吸附的方式啊，其实是看你那个边界润滑油里面的添加剂是什么东西决定的。所以添加剂其实是对那个润滑剂的特性是影响非常大。后面我们会介绍那个添加剂或者是润滑剂的组成。So the first one is physical absorption. So the physical absorption, the surface active molecule of the oilness additive are attracted to the surface by electrostatic force. 所以我们的有油性的添加剂的润滑剂分子的话，是借由静电力吸附在那个物体的表面。So the energy is lower when the molecule absorb on the surface. Physics ocean. The molecule absorbate may attach or detach from the surface without any irreversible change to the surface or the absorbate。所以这个物理吸附的话，就是通常它是静电力或者我们称为范德瓦力，静电力的范德瓦力吸附在那个我们的表面上，它其实不会对我的吸附的表面上造成任何的损伤或者是改变。So the solvent tends to dissolve solute again，就是溶解物的话会，如果你再添加一些溶液的话，它会再度溶解，所以变成是我的 a process encouraged by dilute concentration but hindered by high concentration of polar molecule，就是我们其实是可以去稀释那个浓度的部分。So here we have different lubricant with the different percentage of the oilness additives. So with different composition of the esters, you have different coefficient of friction. So this is basic oil, so it's a mineral oil. We have some additives，所以我们变成是有添加物加上基础油，然后组成的这个润滑剂，所以不同的比例的话会有不同的那个摩擦系数。So this is how you can calculate the solution, the percentage of the solution. So here we have some figure 4.16 and 4.70. So it's the temperature versus the coefficient of friction. So if you increase the temperature, the coefficient of friction will be increased. So here we have some here conclusion here. As the temperature increase, the viscosity reduce so that the friction reduce. So when you increase the temperature, the viscosity will drop. So the viscosity drop means the viscosity of the lubricant getting thinner. So the coefficient of friction will increase. 一般来讲，就是温度增加，粘度润滑油的粘度下降。粘度下降就是等于润滑油的保护的作用就没有了。所以一般来讲，粘度下降的话，就是它的摩擦系数会增加。So for you reading the English textbook, usually the first sentence in each paragraph is important. So it tends to give a conclusion or most important result in the first sentence. 所以你如果读英文书的话，其实每一段的第一句或前两句很重要。它跟我们中文的写法是不一样。中文的话，我们前面都是介绍，最后段落的最后才去有结论。英文的书写方式是相反，所以他们的每一段的前面一两句就直接把重点讲出来，就像这个温度增加的话，粘度下降，所以摩擦力下降，所以他已经把整段的结论都告诉你。所以英文的句子通常是相反，所以他每一段其实都一开始就把整段落要讲的重点就直接跟你讲。This is the difference for the English writing. So the first or second sentence is very important. It tends to give the highlight of the paragraph or the highlight for this conclusion. 通常他们是把重点讲出来以后再去叙述为什么是这样。Here we have the test results. So you have four different type of the foundry lubricant. So first is paraffin and fatty acids, okay, and copper laureth or fatty acid with lubricant platinum. So it's a different solution for that. 所以他也跟你讲的就是白金去润滑，两个界面都是两个相对运动的表面都是白金。我加的润滑剂是这个石蜡油，或者是紫酸，或者是刚刚我们讲的磷酸铜或磷青铜这些东西，它出来会有不同的结果。So this is the illustration to show you how the temperature will affect the alignment or alignment of the lubricant molecule. So this is below the temperature, critical temperature. So the alignment should be in order. And then if it's above the critical temperature, for different lubricant you have a different temperature, different critical temperature for your lubricant can sustain. 所以一旦是到达那个润滑剂或者是它的添加剂不能忍受的那个高温，其实它的排列就被乱掉，有些甚至脱离，所以它就不会有很好的润滑性。所以为什么它的没有润滑性的话，它就变成是不会长长长的纤毛在上面，没办法滑动的话，它的那个摩擦系数其实就会马上就飙高。所以不同的润滑剂有一些不同的临界温度，到某些温度之后，它其实摩擦系数就变大。So the next boundary lubricant mechanism is called the chemical absorption. So for the chemical absorption, it physically absorb boundary additive or detach or decompose or melt at high temperature. It's a kind of a form of corrosion. To form a chemically bound layer, three things are needed. First one, you need to have a chemical active group, and also you have a reactive surface of material. So the surface free from physical absorbed material, so that the chemical reaction can occur. So the temperature gap between the physical and chemical is known as the temperature distress gap. Okay? 所以它这边就是讲这个化学吸附的部分。化学吸附其实是某种形式的腐蚀，它通常就是会形成化学键结，就是你的润滑剂会在你的表面上形成化学键结。那这边讲有三种条件的话，才能形成化学键结，这三种，必须要有很有活性的化学活性的物质，必须要能够有反应的材料才可以。所以那我的表面的话，其实不会有化学吸附的，不会有物理吸附的现象。那这个时候才有可能发生化学吸附。所以我们其实会有另外一个温度就是会产生化学吸附现象。所以它中间会有一个温度的差异，我们叫刚刚叫什么这个temperature distress gap。 So this is a combination of physics sorption and chemical sorption are effective lubrication. So this is a complete method for the foundry lubricant. So you have a different, this is the paraffin oil. The second one is EP, extreme pressure lubricant. And the third one is fatty acid. Okay. And the fourth one is fatty acid plus EP additive. 所以你有不同的添加物，或者是不同的那个添加剂的话，它其实会有不同的润滑特性。当然也有可能我们需要这两种，两种都加起来，所以它加了紫酸，也加了那个超高压的那个润滑剂，所以它因为超高压，所以它这个超高压加上紫酸，所以它两个合成起来。So if you have both additive here, so you have a very small coefficient of friction. Okay. You have a higher tolerance or high suspension for the temperature change. 所以这个就是对温度的话也会很敏感，这个可以使用在很高温的地方。像这个也是啊，高温的时候它把这个摩擦系数降低。So these three or these four are the typical lubricant for boundary lubrication. Okay. So we have some basic requirement or desirable property from boundary lubricant. So the first is the dissolvability in lubricating oil. The second one is the resist penetration by surface asperities. The third one is low shear strength to give a low friction. High melting point so that it provides a solid film protection up to a high temperature. The fifth one is the reactivity with the metal at high temperature to form a metal salt, higher melting point. Okay. So the melting point of stearic acid is 69 degrees of part of copper ferrate about 120, iron chloride 649, iron sulfide 1170 degrees. 我们这里有几个，就是想要的，在边界润滑剂的话，一些我们比较想要的一些特性。 So we have some comparative study from the boundary lubricant and EP lubrication. So for the boundary lubrication, it's restricted to those systems where there is thermodynamic reversibility. If the lubricant reacts chemically, chloride, sulfur, or phosphorus with metal, then it must known as the EP lubricant. 所以这边就是跟你比较一下边界润滑跟超高压润滑。边界润滑通常限制在系统会有一些热力学、热力学转换的地方。那如果是我们的润滑剂会跟那个磷硫、氯啊、磷硫，所以会跟这些反应的，通常就称为高压的润滑剂。So a low load or temperature, EP lubricant are effective. So a lubrication film are designed at a designed location. 所以如果是负载跟压力不够大的话，基本上 EP 的润滑剂是不能发挥作用。So the major difficulty with the EP lubricant is their carcinogenic nature and environmental pollutant. 通常 EP 润滑剂的话，其实会致癌，而且会有环境污染的问题。最大的问题是这样：超高压的润滑剂、超高压的添加剂 ，removal of sulfur compound present in small amounts in petroleum based lubricant require elaborate and expensive refining technique。所以这个就是讲，如果是把石油里面的硫要把它纯化，把它降低的话，就是需要昂贵而且很精密的那个提炼的过程。后面我们会去介绍这个。其实原油的话，或者 crude oil，so you have a different composition of the sulfur in the crude oil. So depending on the composition, the lower sulfide content, you have a higher price for your crude oil. 所以对原油来讲，你的含硫量开采出来的含硫量越低，其实你的价格会越贵。因为我在精炼的过程，我就不需要去移除太多的硫。所以我们的阿拉伯油，还有什么阿拉斯加油、中东油、委内瑞拉油这些，其实都有不同的硫的比例。当然，阿拉伯的是比较好的油，它的硫含量比较低。最烂的是南美洲那个 厄瓜多、委内瑞拉、加勒比海这个硫含量最高，所以它的原油是最便宜。因为我们要在提炼过程把硫拿掉的话，就是要花很多的成本，因为那个是污染物啊。So later on we will discuss the sulfur composition in the crude oil。后面我们那个教科书里面会讲，就是原油的部分，硫含量到底比例是怎么样。So this is a comparative study. You can look at the textbook is better. So we have a different lubrication status. So the first one is for the dry friction, so without any lubricant. The second one is the boundary lubrication. So it's you have only very limited lubrication lubricant. Okay, and then we have hydrodynamic lubrication. This one is seed film lubrication, which means the two surfaces will not have any physical contact. For boundary lubrication, you have most of the stability were in contact. Okay, so you have this three figures. So this is horizontal one is the time. The vertical one is the wear rate. So in any case, you have dry friction, you have a higher wear rate. So if you have a boundary lubrication, then you have a secondary wear rate. And both then are base top curve. So we mentioned before, for the wear rate is the base top curve. Okay, the wear rate in time. 磨耗率的话，就是像浴缸澡盆的形状一样，初期的话磨耗率很大，到寿命终了磨耗率很大，中间的话就是磨耗率比较低。当然你的润滑如果越好的话，so if you have a thick film lubrication, then your wear rate will be reduced significantly. And this is the loading, so if you have an increased loading, the wear rate will also increase. Okay. And the temperature. Okay. So the temperature will affect the viscosity of the lubricant. 温度越高的话，就是润滑油的粘度会降低，就是润滑性能会降低，所以它的磨耗率也会增加。这个是比较。 So next week we will have the class suspension for once because I need to go to Taichung for the project review. So because I have a meeting 10 o'clock in Taichung, so 下礼拜的话就是我们停课一次啊，就是老师要去那个计划报告，so I cannot change the date for the meeting. So please do not come next week. Okay. So I have some experimental study here. It's an online monitoring of the spark gear. So here is a gear. This is a gear. We made a gearbox. Wait. Okay, we'll take a break. So let me introduce some of the experimental results. So this is the study for the spark gear. So we have a torque indicator to measure the torque from the spark gear, torque sensor. So we have a current dynamometer. So dynamometer is the to control the rotational speed for your motor, and also some of the dynamometer can measure the force. Okay. So we have the tools, the number of tools for the pinion and the number of tools for the gear. So this is the gear and this is for the pinion. So this is a modular for the both gear and pinion. From the mechanism design, so you should have a stem modular for your gear so that you can have a transmission. So this is the 2.5 millimeter. So here we have some online sensors. So oil conditioning sensor. So you have two sensors. The first one is to monitor your oil lubricant. The second one is forest wear debris sensor. So you can examine the debris, the wear debris from the spark gear. So it can detect the composition of forest debris. This is a special sensor. Okay. 所以我们这有动力计哈、有那个扭矩量测的 的那个感测器，我们也有那个齿轮箱正时枪，然后我们有驱动的马达，直驱的 DC 马达。那这个是齿轮的齿数，还有那个小齿轮是22，大齿轮是44指，小齿轮是22，那齿轮的模数是这个。所以一般我们传动的话，就是齿轮跟小齿轮这两个要互相传动的话，它的模数要一样才可以传动。这个在机构学上面定义的。所以我们这另外有两个感测器是可以观测那个润滑的油的量，另外一个是那个磨耗出来的那个铁的那个成分，铁的碎屑的那个的比例的部分。So we have some testing results. So, so this is operational time. So maybe we have a fixed rotational speed. This is the duration for the testing. So 1 hour, 2 hour to 7 hour. So so we have a porous concentration. So this is detected from the sensor. So this is measured in ppm. So here is the rotational speed. This is torque measured. So when you increase your rotational speed or increase your torque, you will have a higher wear rate. So it's the same condition, but the duration, time increase, you will have also a higher concentration for the forest wear debris. Yeah. The testing relative humidity is 38 to 52%，相对湿度，这是不同的转速跟扭矩的状况下测试出来的磨耗量，铁的磨耗量。So if you're changing the operational condition, it will change the dynamic of a boundary lubrication. Okay. So this is investigation for the particle size for your wear debris，就是我们磨耗出来的碎屑，它的成分的部分，它颗粒的大小。So this is the timing. So hour, 2 hour, 4 hour, 6 hour, 8 hour, under 500 RPM. Okay, this is another testing condition with 2000 RPM. So in the initial timing, so you have a wear rate pretty high. So as the time increasing or the testing time increasing, the wear debris will decrease. So it's the same as the result here. Yeah. So the wear rate in the initial timing is high. So as the time increase, the wear rate will drop. So this is the testing for that. Yeah. Of course, for higher operational speed, 500 RPM, 2000 RPM, you have, for 2000 RPM, at the timing of 4 hours, you have a higher wear rate than this 500 RPM at the same period of 4 hours. So this one is apparently higher than this one. Okay. So yeah. And this is under loading, okay, under different loading conditions. With a higher loading, what is that load? What is the loading for this one? Wait, paper point indicate reducing wear and increase loading. Zero load to very low load. We have no indication for the numbers here. Yeah. So there's no description for this number here. This is operational time for hours, but this one maybe it's loading. Yeah. Or operational speed. Yeah. So we will check this later. take a small quiz again.我做个小测试，你帮我翻一下。 时间到了，time. Please return the question sheet and the answer sheet. Just give a quick answer for this quiz. It's this curve. So this curve is called the Schreiber curve. So it has three different categories for the lubrication. So you have this line here is the boundary lubrication. In between this and this is the mixed lubrication. For this one, onward is hydrodynamic lubrication. You have a better indication. Maybe it's, yeah, okay. So basically, it's divided by the sliding speed multiplied by viscosity divided by rho, and you can classify into the boundary lubrication in this region, and mixed lubrication in this region, and this one is for the hydrodynamic lubrication. So, so I give you the. I asked you to give the different lambda parameters. So you should give the definition for the dimension that film parameter or specific film thickness here with this definition. And we can classify according to the lambda ratio, or lambda value. So if lambda smaller than 1, it's called the boundary lubrication. And if the lambda is between the 1 and 3, it's called the mixed lubrication. And So lambda between 3 and 5 is called the electrohydrodynamic lubrication. For lambda greater than 5 is called the hydrodynamic lubrication. So this is the most important lubrication theory or lubrication mechanism for our lubricant. So we always using the Strypec curve to classify the lubrication regime or lubrication mechanism, especially for the fluid lubricant. Okay. Any question for today's lecture? We almost finished the introduction of the boundary lubrication. From the example of the textbook, you know, always we have experimental verification for the theory. Or most of the theory, or even this curve, is a comparative study. Okay, you get this kind of curve for the service time versus wear rate or the vertical loading versus wear rate or even the temperature temperature of the lubricant versus the wear rate. So you get this experimental result with different lubrication conditions. So first one is dry friction. The second one is boundary lubrication. The third one is full film lubrication, or we call it thick film lubrication. So next time we will give you the introduction or give you the theory for the mixed lubrication. Okay? So, so next time, maybe 2 weeks later. So next week the class will be suspended for one. Okay. The week after next week, we will discuss mixed lubrication, and then we will give you the lecture for the hydrodynamic lubrication, and then we will have some topic on the lubricant additive. Okay, so maybe in 2 weeks' time, in the class we will pick the final presentation, the topic for each of you for the final presentation. Okay. Yeah. Okay, that is today's lecture. Any questions for today's lecture? It's easier, I mean, for the lubrication theory, you have only 3 or 4 different lubrication. Okay, boundary lubrication you already finished. Okay, dry friction you already study in the friction theory. So you have several different phenomena. You have a different friction theory. For the adhesive friction, for example, or abrasive friction. So in that case, it's a different friction theory. So for the electrohydrodynamic or fluid film lubrication, usually we mix them together. These electrohydrodynamic lubrication is quite similar to the mixed lubrication. Okay, so just the difference is only the percentage of contacting area. Okay. So for full film lubrication, which means there is no physical contact. So the physical contact is 0%. So that's why um, for the application of the air bearing or hydrostatic bearing is in this category. So that means that the bearing surface and the shaft, there's no physical contact. So which means that there's no friction. Or you have a very small coefficient of friction for the hydrostatic lubrication or full film lubrication. Okay. I'll see you in 2 weeks. Okay. Thank you for attending today.